Welcome to the Infrastructure Podcast. My name is Anthony Oliver, and today we're talking about the tricky challenge of safely managing and disposing of the UK's expanding stock of nuclear waste. Because for more than 70 years, the UK has benefited from nuclear technology, generating low-carbon electricity, advancing medicine, supporting industry and contributing to national defence. And alongside those benefits, of course, comes responsibility, because the most hazardous radioactive waste will remain radioactive for many thousands of years. And while it is currently stored safely at a number of surface facilities across the country, as we heard, of course, in the podcast in episode 126 last year, those stores require ongoing monitoring, management and periodic rebuilding. They are secure for the short to medium term, but they're not permanent solutions. Well, my guests today are tackling that very issue. Malcolm Orford is Head of Major Permissions, and Neil Hyatt, Chief Scientific Advisor at Nuclear Waste Services, who are leading the hugely ambitious and challenging project to develop a geological disposal facility for long-term disposal of this waste. And as we'll hear, it's one of the largest environmental protection programs in its history, a deep underground facility between 200 and 1,000 metres below ground, designed to isolate higher activity radioactive waste within engineered vaults and rock formations to keep it safely contained long after today's institutions no longer exist. And progress is being made, with community partnerships established in Cumbria alongside extensive scientific evaluation, engineering studies and international collaboration. But it all comes at a huge cost over vast timescales and in often uncharted technical territory. So let's hear more. Malcolm and Neil, welcome to the Infrastructure Podcast.
Brilliant. Thanks for having me. Thank you.
It's great to see you. Well, let's start with the science, Neil. For listeners perhaps unfamiliar with the concept, in simple terms, what exactly is a geological disposal facility and how does it work?
Great. Well, Anthony, actually, you set it out really nicely in your opening remarks. So it will be an engineered facility that's excavated between 200 to 1,000 metres underground, and its job is to isolate and contain radioactive waste until it has decayed and stabilised and can no longer cause harm to people and the environment. And so it will be an engineered facility, so it's not like a kind of reused mine or anything like that. It will be designed and constructed for the purpose, and will have a series of underground vaults, caverns and tunnels into which we'll place the radioactive waste in purpose-designed containers. And eventually the facility will be filled up, and that waste will be left to evolve safely in situ until the radioactivity has decayed.
Sounds very James Bond-esque. It's clearly very deep. How big is this geological disposal site?
Yeah, so as an illustration in a lower strength sedimentary rock of the kind that we're interested in the Copeland region, something like 36 square kilometres, so 6 by 6 kilometres square. That would be the sort of area that would enclose the underground disposal zone of the GDF. But that won't all be excavated. It will be sort of, tunnels, maybe, 6 to 8 metres diameter, sort of threading through that, caverns, vaults that will excavate to contain the waste. But that's a sort of, rough illustrative area of sort of containing the underground of a GDF.
So as I say, very James Bond-esque.
Maybe. I've not got the Walther PPK, was it? I don't know. Right. But that doesn't get standard issued as Chief Scientific Advisor. Do have a white coat though. Oh,
right, good. That's good. Well, why isn't continuing to store waste safely above ground? I mean, you've been doing it that way. You've been storing this waste safely above ground for many, many years. Why is that a sufficient long-term solution?
Yeah, and as you alluded to, so radioactive waste is stored safely and securely today at around 20 sites around the country, but the time scale required for the radioactivity to decay to a safe level is tens of thousands to hundreds of thousands of years, and on that time scale, the Earth's surface and the human civilizations are dynamic. And change dramatically. So we can't rely on surface environments and surface civilizations to keep the waste in a safe state and prevent harm to people and the environment. And so the purpose of the geological disposal facility is to allow us to exit from that liability and bring it to a safe endpoint. And we do that by choosing a stable geology, and there and perhaps we'll come on to talk about this, there are a variety of different rocks that are suitable for this purpose. But the point about a stable geology is that it changes over a much longer time period, of the order of millions of years. And so if we can be confident in its stability of millions of years, we are confident that the waste will remain stable, isolated and contained for periods of tens to hundreds of thousands of years.
Because the sort of timescale you're talking about for the radioactive waste to decay is tens of thousands rather than millions of years.
Yeah, that's right. So if you consider like one particular isotope we're interested in is plutonium-239. So it has a particular kind of time signature for its radioactive decay, what we call the half-life. And that's like 24,000 years, roughly.
Yeah.
So in 24,000 years, half the plutonium-239 atoms have undergone radioactive decay into uranium-235. And after 10 half-lives, almost all the plutonium is completely decayed. So 10 times 24,000 years is 240,000 years. So that's, kind of a rough parameter for the time period over which we need to assure safety. So tens of thousands to a few hundreds of thousands of years.
And that's what you would describe as a permanent solution then?
Yeah, that's right. So in that environment, the waste will be passively safe. So it won't require human intervention to assure its safety and that it remains in a safe state. There won't be any oxygen in the facility, so that will be consumed. So that gets consumed very early on by corrosion of metal and so on. So it's an anoxic environment. The geology will have the property that water moves very, very slowly through it, if indeed at all. And those conditions ensure that essentially the radioactivity is contained when we consider also the engineered barriers, which no doubt we'll come on to talk about.
Well, Malcolm, turning to you, let's dig in a bit more around the why. With nuclear new build expanding, how critical is the Geological Disposal Facility for the UK's energy future strategy? Not just legacy waste, but I suppose the waste which you're going to be delivering in the future.
Yeah, absolutely. As you mentioned, while the current storage is safe, it's not permanent, and that's dealing with a legacy. But of course, we have the current commitment in terms of the nuclear new builds, as well as the aspirations that go some way beyond that. And I think having that responsible, appropriate, permanent solution for the waste that those processes will discharge, I believe absolutely that's a key component of that. And we see ourselves as a genuine enabler for that wider programme.
Yeah. Some people say no community wants nuclear waste buried near them. What's your honest response? You're involved, at the sharp end of trying to convince these communities. What's your honest response about to that perception? We have, after all, been discussing this particular facility for many decades.
Yeah, absolutely. And I think there's probably two parts to that. The first part is, what does it really mean to live near a GDF facility? And of course, the critical question, the perfectly reasonable question is, how can they be assured that it's safe? And that's where we have, the likes of NEIL and the very strict standards that we would have to comply with to really be able to guarantee that level of safety. And then the other side of it is, of course, what can a GDF bring that genuinely, I believe, no other infrastructure can? Because there are some specifics with regards to GDF that make it genuinely unique in terms of infrastructure delivered. In terms of the transformational element, what I mean is not only the construction jobs, but the operational jobs. This is not an infrastructure project where we turn up, we do some construction, then we disappear. We're talking about 4,000 jobs for construction, but then 2,000 skilled jobs for dozens and dozens and tens of years beyond that. So this really is transformation.
250,000 years.
Well, yeah. We're 100 plus years as an operational site. So for that 100 plus years, we're going to have 2,000 skilled jobs. And in many communities, that would be a genuine transformational element. So that's what we're really excited to be able to bring to whoever does ultimately host a GDF.
And you are, as I said, making progress. Your shortlisted sites are now down to 2 in Cumbria, Mid Copeland and South Copeland. That's correct, I think?
Yes, that's correct, yeah.
Thedlethorpe in Lincolnshire withdrew last year, and a decision was expected in 2025, but it's now been put back, I think, to early this year. Where are you today in the journey towards identifying this preferred site?
So we've been forecasting some time to make a decision in the spring of this year, and we're still on track to do that. We will only make the decision when sufficient information and consideration is available to us to be able to make that. And that decision really will be whether to take one or both of the communities forward through to the next stage of the programme, which is intrusive investigations, boreholes.
Right.
And so that's what we'll be making the decision, and then that decision will be going on to the Secretary of State to government to ultimately decide.
Because you've been going through this process with lots of different communities for the last few years. You withdrew plans, for instance, to include a proposal at Allerdale in Cumbria in 2023, and there's been other communities that have been in the pipeline. I mean, what are the key reasons for withdrawing, perhaps at Allerdale, and what have you learned from that whole experience of doing the research around communities?
I mean, fundamental to the GDF is the requirement to do two things: is to find an appropriate location from a geology perspective, and also to provide a willing community. At Allerdale, we found, and I'll let Neil add to this, but broadly, as we carried on our studies and investigations, it became apparent to it that actually the lump of rock that we were particularly interested in simply didn't have the physical properties. Probably wasn't even large. It wasn't unlikely to be large enough, sufficient to do what we needed to do. And therefore, while it offered a number of other really great aspects to it, obviously in that pretty fundamental regard, unfortunately meant we just couldn't take it forward into the process. Neil, I don't know if you want to any add into that.
Yeah, Neil?
Yeah, that's pretty much it. So our conclusion in Allerdale was that there was unlikely to be a sufficient volume of suitable rock to take the inventory for geological disposal. And to sort of set that in context a bit, what's important in our consideration of a suitable site and the geology, that was determined millions of years ago, right? Because that's when the rocks were formed. Well, in this part of the world, and we're talking about 250 million years ago in the Triassic Age, these rocks were sort of laid down into an ancient channel system, and so the sort of setting of those rocks, particularly in Allerdale, was sort of a long corridor. Now that obviously has some implications for how you might be able to lay out a GDF compared to if you had sort of a nice kind of regular square area. So all those kind of factors kind of become important when you're thinking about whether you've got enough flexibility to host a facility in the underground environment. So essentially our conclusion was, after a period of technical work, that we wouldn't find sufficient volume of suitable host rock. And I've got to say, having been strongly sort of engaged in that work and responsible for assuring its intellectual rigor, it really does stand the test of scrutiny.
Because the criteria, from what I can gather, when you're trying to decide that location, is, as you pointed out, it's the quality of the rock. And when you talk about quality, it's the fissures in it, is it? It's the density of that rock. How would you describe the criteria? Obviously, the size of the bulk of the rock is important, but it's the quality of that. What would you describe as the criteria?
Yeah, so we were looking for rocks which are of intrinsically low permeability. So water moves very slowly through them, if at all. So, and there are sort of three like broad rock types that we're interested in. So you've got evaporites, so rock salt. They're essentially dry. So there is no water to move effectively. Lower strength sedimentary rocks like mudstones and claystones that we've been investigating over the last few years in this program. Water moves very, very slowly through those by a process called diffusion. And then, there are sort of hard rocks, like granites and metamorphic rocks, which have been studied and implemented in the Scandinavian programs. Now, they have very low intrinsic permeability, so water moves very slowly through the rock itself. But what you have to kind of take account of and understand is how water moves through fractures and faults and how those are connected. Right. And that's specific to that sort of rock type largely.
So having fissures and faults is not necessarily a problem. It's as long as you understand how those fissures and faults actually work and interact together.
Exactly. So, and that's kind of, that's where you get into the, what you're trying to do in your site characterization program to demonstrate a suitable site. So somebody like Malcolm can get the consents and permissions. In that example, you would want to have your GDF hydraulically isolated from the fast moving water pathways, and you would need to understand their interconnectivity and how they were working. And that would be part of the site characterization program. So, those issues are much less of a concern, if at all, if you're looking at lower strength sedimentary rocks, for example.
So how confident are you that UK site will ultimately meet both the tests, the suitable geology and the willing community? Malcolm?
I'm absolutely confident. I think what we have to do, obviously, we have communities in the portfolio now. I mean, the whole premise of the policy, the government policy that we're discharging, is to create that environment where communities feel they can confidently, safely have a conversation with us, absolutely reserving the right to withdraw from the process. And it's designed, and so it creates that environment where we can have those conversations and ensure that we give the community the best chance to make an informed decision. In parallel with that, all the geo checks and et cetera, to really ensure that we get genuinely the best site, considering both those critical aspects for the country.
I mean, it's a tricky one because with a project of the timescales you're talking about, delaying it for another 10 years isn't necessarily seen as such a difficult decision. But what does the roadmap, the construction roadmap look like, to you, Malcolm? From decision to receiving the first waste package, when are we likely to? What is the total timescales? What are we likely to see it happen?
So obviously, we are very early days. We've yet to even reach a definitive position on whether or not the current existing communities are the right community to proceed to the next stage. But assuming they did, one or more of them did proceed through, then potentially kind of circa 2030, early 2030s, we'd look to have all the permissions in place to be able to commence the programme of boreholes. That is quite a significant endeavour, with no doubt with a number of rounds, with checks to do scientific consideration results. So that could be a 10 to 15 year programme of boreholes. And then, early 2040s, getting into a place where, we have the permissions. Of course, there's something very important for us called a test of public support. That is a critical milestone that the community have to positively demonstrate that they actively support a GDF being sited in their community. And that is a binary step that we must pass through. Now, it's up to the community, the exact form of that test, how it takes, whether it be a referendum or a series of polls or whatever. But that has to be successfully negotiated and passed. Assuming it were, then we could proceed to actual permissions for the GDF itself. So that the latest planning assumptions is that the GDF would be available for intermediate level waste from kind of 2050 to 2060, and then high level waste and spent fuel from sort of circa 2075. So by anyone's timeline, those are pretty significant durations. With some pretty significant steps to go through from here to that point.
I mean, Neil, you're a young man, but that's probably going to see you into retirement, isn't it?
Well, certainly, yeah. I'm perhaps a bit younger than I look. That's very good of you to say. I think the important thing is, building trust is absolutely important in this, and that takes time, and it's hard won and easily lost. And that's, trust all around the piece, isn't it? It's trust in ourselves as an organisation that we are technically competent to be able to execute a project of this nature. Trust in our external stakeholders in our competence, trust in the public that we can do it safely, and so on. So, my personal way of looking at that is rather less on the milestones and just getting out of bed every day, just keep focusing on like how do we build that trust through technical excellence.
Well, let's drill into a bit more into that, Neil, because you've been at NWS Nuclear Waste Services for the last 4 years, but your background is rooted in academia as a world authority in the field of radioactive waste management and disposal research at Sheffield University and the US in the US at Washington, for instance. Many others, but what drives your passion in this particular field then?
God, I mean, like where to begin, really. I mean, I'm so privileged to be working on a important, environmental project. It's important, to our existence as a civilization. And it's incredibly technically complex. It brings together all the different disciplines. There's a home for everyone. And we need all those skill sets and different perspectives, across a great diversity of technical as well as, cultural ways about thinking about problems. And then, it's actually got to be realizable, so it's great to have dreams and all the rest of it. And we do all the science we like, but in the end, we've actually got to build the thing. And we've actually got to do that, in a way that, is politically successful. So, we have to appreciate the political and, realities of doing that. So it's an incredibly interesting place to be. And, when you've done a lot of science, and the reason I joined NWS was I wanted to bring science in the round, not just my science, into the heart of decision making. And, one thing I can sort of, say to everybody listening to the podcast is, that science and that technical evidence, is very rigorous and used objectively in our decision making. So, yeah.
So how are we doing in the UK? I mean, you've worked around the world and studied this around the world. How are we doing in the UK in terms of our approach to nuclear waste management? There's not many of these facilities in existence, are there?
We do pretty well, actually. So there are sort of 5 cited programs for a geological disposal facility, plus something called the Waste Isolation Pilot Plant, which is already cited and operating in New Mexico, in the USA. And the first GDF for spent nuclear fuel, should take spent nuclear fuel and go into operation in Finland by the end of the decade. And that's in its final phase of commissioning now. So it's kind of ready to go. Now that, in the international programs, as in Finland, Sweden and other places, the inventory of radioactive waste, the material that has to be disposed of, is much less diverse than in the UK. And
that's because of our background in nuclear research from the 50s and 60s.
Right. Yeah. We were a pioneering nuclear nation. We had a civil program which was right at the front edge of innovating nuclear technology. And we had a nuclear defense program, which we maintain to this day. And, that's left us with a legacy of 70 years worth of radioactive waste that is diverse in its inventory, physical, chemical, radiological. And, that's stored in some facilities in the UK, which are, highly hazardous and they need decommissioning and making safe with a sense of urgency. So, our volume of radioactive waste to dispose of is of the order of 750,000 meter cubed. And, that is, much more kind of technical challenge perhaps than other nations have to consider.
Which is why you talk about this multi-barrier safety system. Just go through that about how it actually contains radioactivity over a geological timescale.
Yeah, so the idea of the multi-barrier system is defense in depth. And like any safety critical system, you don't rely on just a single function to maintain a safe state. And, so if you bookend this problem, you've got 2 things, haven't you? On the one hand, you've got the natural geological environment, and that was formed like millions of years ago, as we've said. So we get given that, and our job is to characterize and demonstrate that that's fit for purpose. And then we've got the waste, and kind of we're given that because that was in some cases formed, 70 years ago, in the early nuclear program. And so we have to kind of interface between those 2 things. And so the way that we do that is by what we call packaging. So we treat the waste to reduce to reduce the risk, reduce the hazard. So that might be turning it into a glass, for example. We package it, so in a container, perhaps with a much thicker corrosion-resistant overpack. And then when that's emplaced in the GDF, we will surround the waste package by a protective clay or cement material that stabilizes the waste packages, protects it, and protects the host geology. Because we'll have an open excavation, and we need to fill that voidage. And so our job then is to demonstrate that we've got a suitable choice of materials to have everything kind of coexisting in equilibrium, and that all those individual barriers which contribute to containment of radioactivity through their corrosion resistance or low permeability in the case of the buffer materials and the host geology, that they all add up to give us an adequate safety functioning containment. But we are not reliant on the performance of any one barrier in isolation, any one material in isolation to assure that safe state.
Sounds incredibly complex, but at the same time very, very simple. Right. Malcolm, you have been at Nuclear Waste Services for three and a bit years, but your background is in complex project management with a range of consultants such as Martinsill and Arcadis, but also with projects and clients such as Tideway, Thames Water and Vodafone. How does this compare then on the complexity scale?
In terms of the principle of attaining consents and these large programs in this development stage, of course there are unique technical aspects, but there are a surprising number of common challenges as well. Like any consent preparation, getting that optimum level of design in terms of when you prepare your consents and ensure the consent enables you to do what you need to do. That is actually as many similarities as differences. So in that regard, and of course, at these early development stages, that's where these really big changes can apply, which is really what attracts me to the development stages of projects, almost more so than the delivery. It's nice to see things delivered, obviously. It's lovely to see Tideway having been constructed and getting a tour and seeing what existed online on the plan is now in reality. And even though the years are more significant, the timeline is longer in this project, it'd be the same here. What at one point would exist simply as a line, as a plan, you have to genuinely believe ultimately will turn into a physical asset. So in terms of the challenges, you'd be surprised how many similarities there are across all the different industries I've been fortunate enough to work in.
Well, one of the key challenges clearly is working with communities. How do you describe a willing community? What does it mean in practice? How is willingness tested?
I think and we keep coming back to the word trust, but it's so fundamental. The first thing is to have trust in the principles of the policy, and that is that the community has time to take as long as they want, to ask as many questions as they want, knowing that at any one time they can choose to walk away if they want to. Once you have that principle, then it's just spending time with the community in all its guises, answering those many questions, working things through together. Now, we do have a number of systems in place where we do actively monitor and check and manage, and we carry out surveys where we telephone people up and physically contact people, determine how much they know about the GDF, how they're feeling about it in terms of positive. So we're able to kind of monitor the trend. It's not an overnight, it's not a quick process. Building knowledge at community level, as anyone who's been involved in this kind of development, whether it be nuclear or otherwise, takes a significant amount of time. People are incredibly busy in their own lives, and so it takes time to build that knowledge and understanding of the scheme. Yeah. And in that regard, it's remarkably similar. Because
that's all about addressing fear. It's about addressing misinformation or distrust when they're first entering these conversations. But Neil, I saw on your website you've got a few interesting videos which really try and set out in quite clear, I suppose, public friendly language about what you're trying to achieve there. But I'm also conscious of the fact that a large project like this over such a long time scale, you've really got to engage the thoughts and the views of young people, future generations. It's quite hard to engage them. How do you go about that? How do you make sure that those young voices are heard?
It's a great question. Actually, I think, Malcolm, you had some good insight on this we were talking about the other day, didn't we?
Yes. Yeah. Thanks, Neil. So it's absolutely fundamental, not least because, as you actually say, because the timeline is so extended. We've done a number of things, and we've approached the youth from a number of aspects. So we've gone really from youngsters, and we're developing some programs of work to engage with some real youngsters. We actually had a pilot of the GDF National Youth Forum in 24-25, which is where we reach out and we engage with individuals 16 to 25 for them to learn, understand any sort of curiosity, and to build some knowledge, and from their perspective with the GDF program. And we're going to continue that. So absolutely, we're taking really positive steps to engage, because over the timelines we're talking about, what is today someone who would be categorised as the youth forum?
Well, absolutely, yes.
It could well be a construction, it could well be a worker on the programme in the years to come.
They could be doing your job, Malcolm.
Absolutely.
One of the things I'm also interested in, Neil, your background in academia, is that I think there was a period where studying nuclear science at university was really much on the decline. Is that building back up again? Do people now see the nuclear sector as being a career of choice?
Yeah, absolutely. And sort of to do a bit of a retrospective, I came into this area because I finished my PhD in a different field and went off to work in a metal factory. And a bit of advice: always read the job description. So I applied for a job at the London and Scandinavian Metallurgical Company, which I thought would be very very glamorous. And anyway, the factory was in the bijou town of Rotherham, which was surprised when I eventually got the invite through. But I spent very, very, very happy years there, living and working. And then I was looking around really to get back into science, and I wanted to find a field where I could work, at my own pace, and nobody else would come and think to disturb me. And I saw this advert for a research fellow in radioactive waste, and I thought, brilliant, nobody's going to come and try and get into that. So I went off, and actually British Nuclear Fuels, as it was then, had a programme to invest in universities, and University of Sheffield was one of the recipients of that investment, to train the sort of nuclear scientists of the future, recognising that there was already a very steep decline in capability. And they used to have this plot that used to show that, the skilled workforce went off a cliff edge every time we kind of, closed a nuclear site, which is kind of obvious when you think about it. So since the early sort of 2000s, it's been a great cooperative effort across, the UK universities, and led in particular by people like Sir Robin Grimes, who was government chief scientific advisor in the Foreign Office, and make the most of what we have and work cooperatively together to kind of rebuild that capability. And and we're on a slowly upward trend, I think. And of course, actually, it takes generations to rebuild that, because I think we're now in probably the third generation of my training. So, one of my PhD students, a guy called, very bright guy, Dr. Lewis Blackburn at University of Sheffield, he's now an academic member of staff. He's training, his first cohort of PhD students. So we're sort of 3 generations in to being to rebuilding that capability.
So that capability is being rebuilt, yeah. Well, getting onto the nitty-gritty, Malcolm, then what is the current estimated cost range for delivering this program over its lifetime, or over the next 10 years, or however you define it? And I suppose, following up to that, what opportunity is there for the infrastructure supply chain to actually get in there and start taking advantage of some of this funding?
So I think Neil's actually got the latest figures, which I'll pass on to him. But in terms of opportunities, absolutely. We have had a number of procurements going past, a number of delivery partners for particular areas, and going forward, absolutely, we're going to market, as in any large program, the market is going to be an absolutely fundamental key partner. We simply cannot do it without these organisations. There've been a number of successful procurements to date and delivery partners, and going forward, we absolutely will be seeking more as we go through the various stages. Certainly, as we go towards boreholes, once we reach that position, there's going to be some large critical partners associated with that. And then, of course, as we approach the main GDF itself, We'll be looking for all the particular design and delivery partners for that as well. So some very, very significant procurements coming forward. And Neil, I think you have the latest cost figures.
Yeah, so
give us the numbers, Neil. Give us the numbers.
Yeah, absolutely. So our published estimate, which are actually 2017-18 money values, it's 12 billion approximately to first waste emplacement by 2050 at the earliest, and then a range of 20 to 53 billion to deliver the full GDF over its 175-year mission, depending on complexity.
And how do you balance the long-term benefits with the near-term costs to taxpayers?
Yeah, shall I have a go at that? Trying to answer that question. It's a great question, and if we sort of start off there with the counterfactual of, okay, well, what happens if you don't do the GDF? Well, you're locked into this never-ending cycle of having to repackage waste and rebuild stores because they have a finite lifetime. And that's a never-ending escalating cost. So ultimately, the cost and potentially the risk proves existential, right? So that's just not a sustainable pathway. It will eventually become unaffordable, never mind what else might happen. So it's clear that the GDF is the way out of that liability. It's proven as the best available technology. And what we have to do is find a suitable site, a site that's fit for purpose. And what we need to do is focus on the evidence base to demonstrate that. And we're always mindful about, over engineering or gold plating a solution. That's not what we're about. What we're about is fit for purpose, to assure a safe state of the disposal of radioactive waste. So at the same time, as perhaps Malcolm might talk a little bit about, in delivering the project, we try and maximise the rising value from that investment. And we've also got to sort of do that, the delivery in a way that we're navigating an affordable path for the country and, sustainable financial path for the country. So, it's complex.
Yeah. Malcolm?
Absolutely. We see a genuine both obligation, but also what an amazing opportunity, not only to address this genuine country's need, to deliver this environmental project, but also to offer this transformational effect to a community. Both the investment for the scheme, those jobs that go on for tens and dozens of years beyond, as well as there's additional funding streams as well to go through this. So, to be able to offer that whole package to the government, absolutely, really, really excited to be able to be a part of that, and genuinely believe it's absolutely in our gift to do so.
And the next decisions, they are coming in the spring for...
Well, so the decision coming up in the spring is to whether one or both of the communities in the portfolio are right and appropriate to move forward to the next stage. That is the decision that's ahead of us. And that's what we're going to be, that's what we're focusing on now.
Okay. And Neil, looking ahead beyond that to the 2050s, what for you in your role as a scientist, what does success look like for communities, for government, and for future generations?
Yeah, I mean, ultimately, in terms of the way this program is configured, it's two things that we need to find, and it's an and. So you can't have one or the other. It's a suitable site with a willing community. So that's ultimately, the test of success, isn't it? That we've managed to get both of those things. And I think we have the right policy and strategy to take us to that point. But as we sort of touched on, there's no shortcutting the hard yards. It takes time to investigate and demonstrate that the geology formed millions of years ago will be suitable. We have to work with the host community and build our trust with them so that they can be confident in our delivery of the project and comfortable that it will form part of their vision. And we have to sort of demonstrate value to taxpayers and consumers that we can execute the project and deliver it to time, cost, and schedule, and it will deliver value for money. And those things, they're not quick things to kind of just do on a, what is it now, Tuesday afternoon. They are undoubtedly decadal endeavours. But we're on the right track, and we've got the right environment to be working in, and it's we're just going to keep plugging away and delivering good technical and enabling work and building trust amongst our stakeholders.
Well, I get the impression that you're going to have your work cut out for quite a while yet, but there's lots of really, really interesting progress that's been made, and I'll certainly look out for the decision in the spring to see where you're going next. So thanks so much, Neil, and thanks, Malcolm. It's a fascinating challenge that you're tackling there, facing the UK. So thanks for updating us and for sharing your thoughts today.
Thanks a lot.
Thank you very much. Thank you.
Well, look, sadly, that's all we've got time for on the podcast right now, but there's more in the pipeline as we continue to probe the big issues facing the sector. If you haven't done so already, do check out the Infrastructure Podcast website. That's www.infrastructure-podcast.com, where you'll find background information and all the latest podcasts to listen to and to share. So thanks for joining us. Thanks again to Malcolm and to Neil, and I look forward to seeing you again very soon.